In this episode, we take two names that show up constantly in security conversations and make them useful for beginners in a very specific way. Not as documents you must memorize, but as ways of thinking that help you make defensible engineering decisions. People often talk about NIST and ISO 27001 as if they are checklists or rulebooks, and that view can make them feel intimidating, especially when you are new. The reality is that both represent structured approaches to managing security in a disciplined, repeatable way, and the exam tends to reward candidates who can apply that discipline to system decisions. You do not need to quote document numbers to think in a NIST-like way or an ISO 27001-like way. What you need is to understand the habits they encourage, such as clarifying scope, identifying risk, selecting controls that match risk, documenting decisions, producing evidence, and improving over time. When you translate those habits into engineering choices about requirements, architecture, assurance, and operations, you build security that is easier to justify and easier to maintain. Our goal is to show how this thinking helps you choose what to do, what to prioritize, and what to prove, without turning the topic into a paperwork exercise. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyber.author.me in the Bare Metal Study Guide series. A helpful first step is to recognize that NIST and ISO 27001 both start with the same basic assumption. Security has to be managed as a system, not as isolated fixes. That means you need a defined scope, a clear understanding of what you are protecting, and a consistent process for deciding what level of protection is enough. In practice, scope answers questions like what system, what environment, what users, what data, and what boundaries are included, because a vague scope leads to vague security. Once scope is clear, both approaches push you toward risk-based thinking, meaning you identify what could go wrong, how bad it would be, and how likely it is given your context. This matters for engineering decisions because it prevents you from overprotecting low-value areas while underprotecting critical ones. Beginners sometimes assume security is about applying every control everywhere, but structured thinking teaches you to focus effort where it reduces meaningful harm. On the exam, many questions are essentially asking whether you can reason from scope and risk to a sensible decision, rather than choosing the most extreme answer. Another shared habit is the idea of control selection as a deliberate, justified choice rather than a default template. In a structured approach, you do not pick controls just because they are popular. You choose them because they reduce specific risks and support specific requirements. That means you must be able to explain why a control exists, what risk it addresses, and how you will know it is working. This is a major bridge between frameworks and engineering, because engineering decisions should be defensible, and controls are part of that defensibility. A common beginner mistake is to treat controls as magic shields, as if installing a control guarantees security, but structured thinking demands evidence and context. If a system has high availability needs, controls that create fragility may not be appropriate even if they sound strong. If a system handles sensitive records, controls that improve auditability and integrity might be emphasized. Translating this mindset into exam answers means you look for options that match controls to risk and constraints rather than options that sound universally correct. One of the most practical ways to translate structured thinking into engineering decisions is to focus on lifecycle, because both NIST-like and ISO 27001-like approaches treat security as ongoing, not one-time. Systems are built, deployed, changed, and maintained, and each stage can introduce new risk or weaken existing protection. A structured approach encourages you to plan security early, design it into architecture, verify it during build, and maintain it through monitoring and change control. This aligns directly with security engineering principles like traceability and assurance, because you must be able to show that security requirements were implemented and remain effective. Beginners sometimes think that passing a security review means the system is secure forever, but structured thinking emphasizes continuous improvement and ongoing evaluation. In practical terms, this means you expect baselines to drift, threats to evolve, and business needs to change, so you design processes to detect and manage those changes. On the exam, options that include ongoing monitoring, disciplined change control, and periodic reassessment often reflect this mindset. A key difference in how these approaches are often used is where they put emphasis, and understanding that difference can help you make better decisions. NIST-style thinking is frequently associated with detailed guidance, structured categorization, and control-oriented planning that ties risk decisions to system characteristics and assurance activities. ISO 27001 style thinking is often associated with an information security management system, meaning a management structure that defines policies, roles, risk treatment decisions, and continual improvement practices across the organization. Even if you do not study the formal language, you can translate these emphases into practical questions. For a system decision, a NIST-like approach might push you to ask what system category and impact level you are dealing with, and what controls and evidence are appropriate for that level. An ISO 27001-like approach might push you to ask whether the organization has defined responsibilities, policies, and measurement so that security is consistently managed and improved. In practice, both questions matter because systems do not succeed without both technical controls and management discipline. On the exam, recognizing whether the scenario is mainly about system-specific assurance or about organization-wide management consistency can guide you to the best answer. Another way to make this practical is to think in terms of risk treatment options, which is a structured way of deciding what to do about risk. In plain language, you can avoid the risk by changing the design so the risky activity does not exist. You can reduce the risk by adding controls. You can transfer the risk by shifting responsibility through agreements, or you can accept the risk when the cost of reduction is not justified. Security engineering uses these choices constantly, even if people do not name them. For example, if a system cannot securely expose a service to the public, you might avoid the risk by changing the architecture to use a safer interaction model rather than exposing the service directly. If a risk is moderate and reduction is feasible, you implement controls and verify them. If a risk involves third-party services, you might require contractual commitments and monitoring, which is a form of transfer paired with control. If a risk is low and the cost to reduce it is high, acceptance may be appropriate, but acceptance should be documented and tied to accountability. Exam questions often test whether you recognize when risk acceptance is appropriate and when it is irresponsible, and structured thinking helps you make that distinction. Documentation and evidence can sound boring, but they are essential parts of translating frameworks into engineering, because engineering decisions must be traceable. Traceability means you can connect a requirement to a design choice, connect that design choice to an implementation, and connect the implementation to verification results and operational monitoring. Without traceability, you cannot convincingly claim that the system meets its requirements or that it remains secure after change. A structured approach encourages you to document decisions not for bureaucracy, but to preserve intent and support accountability when people, teams, and priorities shift. Beginners sometimes believe that if the system seems secure, documentation is optional, but that belief breaks down when incidents happen or when audits require evidence. On the exam, answers that emphasize establishing clear documentation, maintaining evidence, and connecting controls to requirements often reflect a mature security engineering mindset. Evidence is not the enemy of delivery. Unmanaged security surprises are, and evidence reduces surprises. Another practical translation is the idea of measurement, because both approaches expect you to know whether security is working, not just to claim it is. Measurement in security engineering might include whether access rules are being enforced as intended, whether monitoring is detecting suspicious behavior, whether vulnerabilities are being managed within acceptable timeframes, and whether incidents are being handled effectively. The exact metrics are not the point here. The mindset is that you choose indicators that reflect your objectives and risks, and you review them regularly. This prevents the predictable failure mode where a system passes an initial review and then silently degrades because nobody is watching. It also supports continual improvement because you can see where controls are effective and where they are creating noise or gaps. Beginners may worry that measurement is too advanced, but basic measurement is simply paying attention to whether your protections are producing the expected outcomes. Exam scenarios about repeated incidents, lack of visibility, or uncertain security posture often point toward missing measurement and monitoring practices. A structured mindset helps you recognize that the solution is not just adding more controls, but creating feedback loops that reveal reality. It is also important to connect structured thinking to the human side of engineering decisions, because frameworks assume organizations have roles, responsibilities, and governance. Practical engineering decisions often require knowing who can approve changes, who can accept risk, who is accountable for monitoring, and who responds when something goes wrong. Without that clarity, even strong technical controls can be undermined by inconsistent operation and uncontrolled change. ISO 27001 thinking, in particular, reinforces that security must be managed through leadership support, defined responsibilities, and continuous improvement processes that survive personnel changes. NIST thinking reinforces that system authorization and ongoing assessment require clear accountability and evidence. On the exam, when you see scenarios involving unclear ownership, conflicting priorities, or repeated security issues that never get resolved, the best answer may involve governance and management system improvements, not just technical fixes. Translating framework thinking into decisions means you include people and process as part of the system, because they are part of the system. As we close, the main takeaway is that NIST and ISO 27001 are most useful when you treat them as disciplined habits that guide real engineering choices, not as lists you must memorize. Both push you to define scope clearly. Think in terms of risk. Choose controls that match risk and constraints. Document decisions for traceability, and produce evidence that security requirements are met. Both also push you to treat security as ongoing through monitoring, measurement, and continual improvement, because systems change and threats evolve. When you face an exam scenario, you can translate this thinking into simple questions. What is the scope and objective? What are the key risks? What treatment choice is appropriate? What controls and evidence best fit? And how will the system remain secure over time? Those questions lead you toward answers that are defensible and aligned with security engineering rather than answers that chase buzzwords. If you build this structured mindset, you will find that many exam items become less about remembering a detail and more about applying a steady process of reasoning that keeps security connected to real system outcomes.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.